Incremental routines. So now you know what neural review is. I have a video on that in case you haven't seen it. Okay, now I know how actually it works in Supermemo. When I can go neural and the queue, neural queue and all of that. But the question remains how this is calculated. How Supermemo weights. This will be the first element. You will see it, that's the second, the third, and so on. How does the spreading activation? You can know that. So I will go neural from the same place as the last video, from my root element. And there's one option if you go to Toolkit and you go neural analysis. This says build a neural queue over the current element, same as going neural, by the way, and report the paths used in the spreading of activation. Let's do that. Nice. In this case, I got errors. Incredible. Now that I'm recording this, is virtually the first time that I get errors. Fantastic. By the way, I have a previous attempt here, just in case it's messed up. Okay. So first I have the activity. Okay. Then the collection, because you can go neural with multiple collections. The date and the version that I used. Nice. Then it says, every time it will say the action. I will make this bigger. It says spreading activation. It says the action. I think it always will start with spread activation, but you can also have following concept links, following inter-element links, root article, adding a new element, and so on. Keep in mind, this is the formula. This is actually how it's calculated in Supermemo. From Supermemo 17, I'm assuming 18 and 19, it's exactly the same. So associated concepts are weighted 1%. Instead of using the decimals, I will be using the percentage, so it's easier to convey. 1%. Links that are added, remember I have a video on that. You can link any element in Supermemo, not just concepts. We'll have a combined priority of 5%. Descendants, that means childs of any level, can be even 2 levels of hierarchy down, 3, and so on. They will weight 16%. And siblings, meaning the same level of hierarchy, 26%, and up to 50% have, in case they are unrelated, containing full articles. A good example of this in my collection would be the imports. Like this. Those are siblings, but are different articles, are full articles that they aren't processed yet. So this will get up to 0.5 or 50%. Nice. So now let's go back to then size. This is the layer size. And it always starts with 0, then you get something. It's the same as the video I did before. Let's say I have 100. When I do some repetitions, this number gets increased because a new layer is created. Nice. So this is the size that are actually in the layer. Then the element. In this case, I started with my root element. Then link priority. This priority is using all of this. So it can be as low as 0.01 or 1%. And as high as 0.5%. I don't know, I think that's because itself it will be 0. Because it's a starting point, I think. I don't know, it's not that well documented. Then you have the element priority, which in this case it's 75, is this priority. 75.7%, which is rounding. There are more decimals here. And this is without rounding. And then I have the layer priority, which is, this will be the first layer, and every time, so here I have the size of 0. If I scroll down, now I have 27, 28, 30, so at some degree, this will jump the size. Something has been added, and perhaps is a different layer. I don't know. It's not documented anywhere. So the only thing mentioned is that at each repetition, more layers of conceptual networks are explored. Just goes a few layers, yeah, because usually you won't do so many repetitions, and there's no way to calculate all of this. Back in the day, I think it was consuming. Exactly, it's unlikely to go through to just more than a layer, and is for performance reasons. Yeah. So that's everything. Everything I have shown to you now is all there is in the documentation. So the layer priority, I think it's based on this, but yeah, I think we can just discard it. So element priority, we know that for sure because it's the element in Supermemo, super easy to check. The link, it will be kind of cumbersome, but it can be calculated. So then let's follow with the example. Is what I will see next. I'm still in the same place. That is the root element. Then it jumps eventually, adding a new element. Okay, and it goes to collecting seedlings. In this case, it's this folder, 2024B, which, oh my god, it's the one I haven't collapsed. Yes, it's a child of the root. In this case, it's a folder. In this case, it's virtually the worst case scenario, because it got to the place that I only have full-fledged topics without no processing. So they are sibling unrelated. This means that most of those priority link priorities, will be very close to the maximum. If you remember, 0.5%. Let's check that. Okay, so it's almost close to 1. Nowhere in the documentation says that. Okay. This looks more related, yes, up to 0.5%. And now, because it has been added, the size has increased by 1. Yeah, easy to follow. Another one, so increases by 1, even though the element priority, by the way, it's super low. It's very close to the minimum, that is 100. But why the link priority is almost 1 as well? Doesn't make much sense. If we go back, it seems that the maximum is 0.5%. Where on earth I get the almost 1? I don't know. And you see that it's repeating the same, that the link priority is close to 1 every time, 0.8, and so on. Okay, in this case, that's not a good example, because there are no meaningful relationships. Let's try and go to a different place. And I will do the same as I did the last time. That's the beauty of recording myself. Finally. So last time, in the previous video, I also went neural, but I got something different. In that case, I got all of that, especially from botany, then the Arthur William, and so on. This shows that every time that I go neural, even if it's from the same starting point, I will get a different experience. I won't get the exact same neural cue. That means it's a non-deterministic calculation. Just like ChatGPT, I can ask to ChatGPT a question, and I will get a very similar answer every time, but not exactly the same answer. So it's the same thing. Now, if I go back to the root, that is the first try I did off screen. And you will see that in this case, I go new element, to root, it goes to humanities. Okay. So let's try it. I will go to the concepts, and one of the most richer concepts I have is this one, space repetition and incremental reading. And I will go neural. But damn, I cannot do the analysis here. Well, what I can do is list, whatever list. The element window shows the concept. It's all black because that was applied done. Even if it's done and it's dismissed, I gotta still go neural. And instead of going neural right away, I will go with the neural analysis. 64 errors, oh my god. Nice. So now I start the spread activation from this concept. Follows the concept links, okay, adds a new element. Let me make this bigger. So look at that. Descending relationship. Two approaches to learning programming. Top down and bottom up. That's the topic that has this concept set. Yes, it's linked because it's inside the concept group. And this is fascinating. It's a very good example because look at the element priority. Again, it's super low in 92%. Keep in mind, 100 it's the bottom. The higher the number, the lower the priority. So that means that I get an element of a very low priority, but it's because it's high priority with the layer and the link. Remember, closer to zero the better. What we have seen in the first try, going neural with from the root element, the link priority were almost close to 1. That's the worst case scenario. That means that the semantic relationship is almost meaningless. This means it's very meaningful. It's very close to 0. Very close to 0. Even though the element priority is very low, the relationship is very high. Adds a new element. Then the size is 2. Nice. Then repair. This, based on the title, I can already tell you this is from Supermemo documentation. Then I have repair options, Supermemopedia, something I imported from there. Personal information management, close interval from the Guru website. So you know that the element priority is not that relevant. What weighs a lot more is the link and layer priority. So that's how you can know how it's calculated. And if we go back to the end, here are the errors. Executing operations beyond the activity range. Operations done and maximum. Yeah, it exceeds by 1. Yeah, all of the errors are the same. And every error just add one number. It is the same thing. But keep in mind, this only needed 1 single second. So it's done for performance reasons. I mean, you can do a few hundred in a second. Perhaps it's because of the size of the link registry and so on. Now, what will be interesting, I will keep this file and I will go neural again from the same place. Nice. So now let's compare, because usually what will happen is that I will have done some repetitions while doing the neural spreading activation, the neural queue. And since I will do some repetitions, I will change the status of some elements that were outstanding and now are not outstanding anymore. They will schedule in the future. Therefore, they cannot appear again. Since I haven't done no repetition at all, let's see how different that is. Will I get exactly the same? Let's find out. Yeah, so far the same. 72 up to here is the same. Okay. Learning programming. Hey, that's already different. Neural creativity. By the way, it's very ironic because the topic it's about neural creativity. What I'm doing, it's the exact same article that I got this. Neural creativity. Oh my God, I'm going full circle with this. The point is that discovering learning experiments, space repetition in the classroom. That's different. I had registry window, repair options. So that shows that it's not always the same. It's non-deterministic. I haven't changed anything. I haven't done any repetition at all. So the starting point is the same. The calculations are the same in the link, layer, and element priorities. But when I increase the size becomes 2, so something is added. The first time I have adding new element. Here it is, adding new element. This is different. Following inter-element lengths. But look at this. I got it's the same concept. Look at the number. 1797. If we take out the title that can vary, it's the same concept. The priority of is the same of the element and the link on the layer. But then the descendant, the next one, this is where it changes. Oh look, the link priority exactly the same. The layer priority exactly the same, 0.1. The element priority is what changes, 62 versus 92. The source of the activation is the same thing. Perhaps there is a draw because it's the same number. So you could get any of those, I don't know. Here it is, quite at the beginning. Makes sense, 62%. Yep. And now here you have a ton of childs. And then even a second level, a third level, and then the items. Every repetition you do, you create a new layer. So the layer priorities are taken into account, and some just are taken out, some come in the queue, stuff like this. Yeah, keep in mind now, I'm doing a backup. I'm using a backup, I can mess around. Don't do this with your Zen collection. So take home message. The spread activation can start and follow by concepts, interlinks, and many other ways you can actually have this. That is why creating links and having a rich collection of concepts and links is meaningful. Not just meaningful, but actually kind of required to have a meaningful usage of the neural review. Linking concepts, not setting the concept of the element, but linking other concepts. Right-click concept, link concept, or link other elements. This will be the second one. Receive high priority. Then the priority, so the element itself, what we have seen, the element priority, the higher, the better. In this case, I mean not the better, but the most likely it will take into account. That doesn't mean if that relationship already is very high, the element priority can be low. It's actually close to neglect. Then the siblings, they share the same parent. Then the children, so the actual element is the parent, and you go hierarchy down. Then the parents of whatever is hierarchy down, and also then you go hierarchy up, which will be the lowest priority. That means that if you have a collection very rich, it's very safe to assume that you will do this. Meaning you will be crawling those links. And yes, you will have all of that, but it will be so far in the queue that it's unlikely you will do those repetitions. So you go and navigate and do the outstanding queue in a more meaningful way. Meaningful, now is pun intended, because you go by meaning, by semantics. Right, this is related. It doesn't have the same concept necessarily. It goes through the link that you have put explicitly at some point in the past. So when you want to go neural, it's because of creativity. And here on the website, you have some examples. A medical diagnosis, solving a software problem, a bug, or a use case that you don't know how to tackle, creative writing, or forensic science. Those are some examples, there are more. But the thing is that, hey, since I will see all of these repetitions next to each other, I will be activating all of the mental models. I have this super fresh in my mind. And then is when I can make new associations with the information I already know. That, hey, I have this piece of information, this other one, but it's the first time I'm connecting those. That's the superpower of spreading activation, doing neural review. But this is costly. I think even says that in the article, that you have to put a lot of effort making the links, linking other elements, and all of that. Hope this has been helpful. Please let me know if you tried, what you get, your experience. Do you think it's worth? If that's the case, please convince me. Try to convince me so I use it. Because now I only have 8 concepts. Then going neural for me is quite arbitrary because as the start of the video, the link priorities are close to 1, so are very weak relationships. Nothing more to add today, and see you incrementally.